So with these equations, the first thing that we're going to do is we're going to take an equation that's in quadratic form and change it into vertex form. So I'm going to have you do that in your homework. It doesn't say that in the directions, so take good notes because this is what I would expect you to do in your homework. It doesn't say to do that in the directions in the book. So what we're going to do is we're going to take f of x equals x squared minus 4x minus 5, and we're going to change it into vertex form. So probably one reason why chapter 2 is happening now after chapter 10 is to change it into vertex form. You need to know how to complete the square. And we just did a ton of practice with complete the square. Remember? Complete the square? Okay. To do this, you're going to take x squared minus 4x plus something. But if I add it to one side, what also do I have to do? I have to add it to the other side. But I want the other side to still say f of x. That's not a variable over there. I want it to say the function at x. So instead of adding the square to the other side, I'm going to subtract the square on this side. So when I add an amount and subtract an amount, what am I really adding here? 0. So it's going to change the appearance, but it's not going to change the value of the equation. It's just going to make it look a little different. And then I'm going to write my minus 5 at the end. So we're changing the appearance of the function, but not the value of it. So what's going to go in my square? 4. So what's going to go in this square? 4. So now we can factor it. F of x equals x minus 2 squared minus 9. But we are putting it, this is when you marked out, we are putting it into vertex form. And why would I want it into vertex form? So I can find the vertex really easily. Otherwise, I'd have to do like negative b over 2a and then take that number and plug it back in. But this way, if I take it and I put it into vertex form, what's my vertex?
2 negative 9.
And what's my AOS?
2.
X equals 2. So this is what I'm going to want you to do on your assignment. I'm going to want you to change it into vertex form, then find your vertex and your AOS, your y-intercept and your x-intercepts, but use vertex form to do that. So I'm going to find my y-intercept. There are different ways of finding the y-intercept. We're going to use the vertex form, not the original question. Okay. So we'll do f of 0 equals 0 minus 2 squared minus 9. 4 minus 9. And then we're going to practice finding the x-intercepts from vertex form, not the original question. So you would do it a different way if you were using the original question, but we're using vertex form. How do you find the x-intercepts? Make y 0. And then when it's in this form, what would I do? Add the 9. Oops, thinking ahead. And then from here, once we have squared by itself, we're going to do what? Square root, but if I square root it, I'm going to do something else. Plus or minus. There should be 2 answers, hopefully. And then set it equal to x. So we have 2 plus or minus 3. So I've got one answer, 2 plus 3. The other answer, 2 minus 3. 5, 0, and negative 1. Next question. So that one's pretty easy. The next one has a little bit extra step. Why is this one a little bit different than the first one? Oh, by the way, I changed it. See how yours says minus 8? Make it plus 8. Right now, go make it plus 8. Otherwise, you're going to have problems.
Just take the negative, like it's divided by
Kind of.
Like a negative one. then-
So this negative sign right here, you can't do complete the square if the negative sign is there. So you have to factor out the negative sign. So my first step is going to look like negative, or -1, parenthesis, x squared, minus 3x plus something, minus something, and then plus 8. So I did not take the negative sign out of the 8. That's why it's not in the parentheses. I only took the negative sign out of the x squared and the 3x. So when you take that negative sign out, and man, a lot of you messed this up on that test that I'm grading, test. Yeah, test. The test I'm grading, a lot of people took out a negative sign but didn't take it out of the second term. So we're taking out the negative sign, and then the 8 doesn't get affected by that. All right, what goes in here? -3 divided by 2 squared. What goes in there?
9.
Don't give me a decimal. 9/4. So what goes here? Negative. Why? Because you took a negative out. And whatever number you take out, you have to multiply it by that number before you add it to the other side, or in this case, subtract it. Remember that rule where you have to multiply before you add it? Okay, same rule. It's just the box is on the other side this time. That's the only difference. So now we have negative, parenthesis, x. What goes in this spot? -3/2.
Wait, is that the same reason we're adding 8? Like, on that first, like what you were explaining? Like, are we adding 8 because of the -1?
No. We're adding 8 because I told you to change it to a +8. It was wrong on the printed version. Did you change it to a +8 in the original question? That's why it's +8. Okay, so now I'm going to add these together. So I'm going to add together positive 9/4 plus 32/4. Where did I get that number from? 8. Okay. So we get 41/4. And that's vertex form. So what's our vertex? 3/2, positive 41/4. What's our AOS? X equals 3/2. We're going to find our y-intercept. F of 0 equals negative parenthesis 0 minus 3/2 squared plus 41/4. So it's going to give us negative 9/4 plus 41/4. We add fractions. -9 plus 41 is 32/4, so I get 8. Y-intercept 0, 8. X-intercepts. Again, we're using the vertex form to do all this stuff today. 0 equals negative parenthesis x minus 3/2 squared plus 41/4. So using this form, what am I going to do first? We have the 40, so I get negative 41/4 equals negative x minus 3/2 squared. Right, we can multiply or divide both sides by -1. Either. Multiply or divide both sides by -1. Now what should I do? Okay.
So before, like, we had a negative 9/4 plus 41/4. Doesn't that go to a positive 9/4 because there's another negative?
No, it was negative originally. Where am I? How high am I going up?
Yeah.
This one?
Yeah.
It was minus. and then a negative.
That's plus.
So it's plus. Which is how we got 41. And then down here we're squaring. Here we're squaring a negative, which becomes positive, but then the negative is out front, so it's negative here. Okay, so now what am I going to do with this stuff? Okay, well what if I square root? Plus minus, right? I'm going to get plus minus square root 41 over 2. Oh my gosh, how did I get that? You square root the top and you square root the bottom separately. So when I square root 41, I can't do that, but when I square root 4, I can. Oh, I did. What?
Why did you change it to the plus? Why is there a green line? 3 times the negative 1.
Because, yeah, I didn't write what I should have written. It was negative on both sides, so I multiplied both sides by negative 1. So that we could square root a positive number. That's the green multiplied by negative 1. And then I square rooted it. I was trying to give myself less to write. Okay, where are we? Then we need to add 3 halves, so we have x equals 3 halves plus or minus square root 41 halves. There's another way you might see this question or this answer written. You might see it written as 3 plus or minus square root 41 halves. Since it is a common denominator, we can add the numerators together over the common denominator. Either of those would be fine. Okay, how do we know that we did all this work right?
Graph it.
So we're going to check it on the calculator. The bottom section on your notes is for you to write down steps used on the calculator, because if I'm teaching it in class, I'm not going to reteach it to you on a quiz. I'm not going to spend an hour of my time reteaching you this entire lesson because you won't take it. So if you want to remember how to get the vertex, the y-intercept, and the x-intercept on the calculator, there's all that spot, those places at the bottom where you can write notes to yourself. Okay? And especially do not ask me to help reteach you an entire lesson if you're on your phone during class. Because that's not going to happen. All right. So go ahead and type in, let's type in the original question, not the vertex one, but the very original question was negative x squared plus 3x plus 8, right? Was that the original one? Okay. And when you hit graph, if your graph is not all pretty and like centered, you can hit zoom 6 to make it look the same as mine. If I'm going too fast, I can't see everybody's calculator screen. So if you're stuck somewhere and you need me to come, so you just call me over as soon as possible. Don't wait till, like I've done 18 things. Call me over as soon as possible. All right, I just want to warn you that sometimes these things that we're about to do won't work when the entire graph isn't showing. So I feel like this would be a good one to change the window so we can see the whole graph. Doesn't need to change drastically. Not really. Just need it to go up a little bit more. So if you go to your window, what's going to make it go up? The y maximum. We go to the y maximum. Maybe make that 12. Hit graph. And that looks a little bit better. So you can see the whole graph. Are your axes gone? So the second and the middle zoom thing. Okay. Now what? We're gonna find our, what's the first thing? Vertex. Everything that we need is under second calc, which is second trace, which is the calc button. But if you look at second calc, you go under that button, second trace, nothing says vertex. Because sometimes it's not called a vertex, but it is always called a maximum or a minimum? Which one's the one where the parabola is upside down? Is that a maximum point or a minimum point? It's a maximum. It's at the top of the hill. So we're going to choose maximum. So you have to know if it's a max or a min. This one's a 4, maximum. And then it says left bound. And I'm going to tell you what I think is the easiest way of doing left bound. So you're looking, and we're looking at the vertex, and I want to pick any number that is to the left, the x value that is to the left of the vertex. Can somebody yell out a number that is to the left of the vertex?
0.
0, -2, -10, any of those numbers are to the left. I'll just choose -1. Nobody said that one, but I feel like it. When you do, and you type in, I'm sorry, I probably won't wrote this. All I did was hit -1, enter. I didn't move my arrow, or I didn't use my arrows to move. I just typed -1, enter. When you do that, it brings like a little boundary line.
Does it really matter what we think?
No, as long as it's to the left. But it might matter the fact that you didn't change your picture so that you can see your
I
vertex.
tried, kept like, but nice one.
That's well, then that's like this is go to window. Go down to what? On max. Now you're gonna have to go back and do second trace. Choose your maximum. Okay, at this point it says right bound, so we want to pick something to the right of that maximum point. Somebody yell out to the point, to the right. 6, I heard a 6. So hit 6, enter. So now the calculator is only looking within this boundary. And where that is really important is when we're going to have like not parabolas, but when we have equations that have lots of ups and downs, the calculator needs to know to look only in between certain boundaries. Right now, there's only one, but there might be like 4 maximums in a graph. So we're looking at only this maximum. And it asks guess. So where do you think it is approximately? 1, 2, 1.5, somewhere around that?
5.
It doesn't really matter as long as it's in the middle. Just type something. I'm going to hit 1, enter. And it tells you the maximum is at 1.5 and then 10.25. Does that coincide with what we wrote on the paper before? Is that the same? What did we didn't write 1.5. What did we write? 3 halves. We didn't write 10.25. What did we write? Is your hand up, Alex? No. Okay. 4 and a fourth, or 40, 1/4, 10 and 1/4. That's okay. What? Yeah, we're just checking to make sure we did it right. So what we're doing is we're learning how to do it on the calculator so that you have the ability to check your answers. However, on a quiz or a test, you might have to do it all by hand. So you've got to know how to do it by hand, but I want you to know how to do it on the calculator too. Okay? So I see some of us have different things. Some of us have different answers for the maximum. It's kind of hard to see Lyndon's on here, but yeah. Well, that doesn't work. Is yours? No, yours isn't any. Okay. Anyway, his says like 1.4999983, and mine says 1.500003. And I did this in the other class, and it said 1.50000, and I think it was a 6 in the other class. Like, there is a slight inaccuracy by using the calculator. The answer really is 1.5 exactly. There's no decimals. But when that happens, if you get like a bunch of decimals that pretty much rounds to that number, it's probably an inaccuracy in the calculator. But we're just trying to check to make sure we're right. So we're right. Okay. Next thing we're going to do is learn how to do the y-intercept. Y-intercept is by hand. How did we do the y-intercept?
Plug in 0 for
Plug in 0 for x. So there's a way that you can plug in numbers for x and it'll tell you the answer. You go back to second trace, which is the calc button, and it's value. Number 1, value. So second trace value, when you choose that, it says x equals, and you type in 0, enter, and it tells you 0. So that is a good way of checking our y-intercept. That one I would think would be the one that you feel most confident about, hopefully. finding the y-intercept. All right, the last thing is finding our x-intercepts. So the x-intercepts are also under second trace. But when you go under second trace, it does not say x-intercepts. So we have to know the code word for x-intercepts. Yeah. To get the x-intercepts, you make the function equal to 0. You make y equal 0, the function. So they're called zeros. That is another word for finding the x-intercepts, is finding the zeros. So we're going to choose 0. Number 2. And it says left bound. So we're thinking x-intercepts. You cannot do them both at the same time. You have to do them one at a time. So let's just choose the left x-intercept. What is something to the left of that x-intercept? -3. What's something to the right of that x-intercept? 0. So now we have a window that has only that x-intercept in it. What's approximately that x-intercept? Yeah, and you don't even have to be that accurate. I just put -1. It's definitely not -1. And then it tells me the answer, -1.701562. So what I'm going to do in my notes, so I'm going to copy that in. It was -1 point, I don't remember, 70. Okay. There is not a way for the calculator to tell you the radical answer. It's going to give you a decimal approximation. So we'll be able to check that in just a moment. I'm going to go and get the other x-intercept in decimal form. So we're going to, again, do second trace. We're choosing which of these for x-intercepts? 0. And it says left bound, so I'm going to pick something to the left of the other x-intercept. 2. And I'm going to pick something to the right of that other x-intercept. 7. And something in the middle. 5. And it tells me 4.701561. So do I have the right x-intercepts if the decimals are these? Well, go to your calculator, your calculation screen. Oops. And let's type in what our answer was. What was our answer? 3 plus square root 41 over 2. Was it 3 or was it -3? It was 3. And then 3 minus. So if you don't have the same calculator as me, if you have one that doesn't take fractions like mine, you might want to practice this to make sure you know how to correctly type it in. And make sure you get the same answers too, if you have the older models. Here's a nice one.
Well, I don't know if it's going to.
So
You
you
want
have
to
to
put the parentheses in front of that?
You need to have an extra set, yeah. You good? Are you working? Yeah. You don't have fractions on your calculator? Uh-oh. All right, where were we? All right, so did we have the correct x-intercepts? We did. But if you tell me the decimal version on a test, where I expect you to tell me the radical version, you're not going to get credit. Because I want to know that you know how to do it by hand, and then you could also check it if you need to. All right? Good?
Yeah.
All right. Let's do the next one. From beginning, we are first going to do vertex form. And to do vertex form, can I have that 2 when I complete the square? So I got to factor it out of the x squared and out of the 8. But not out of the 7 I'm just gonna leave that out here. Bless you. So I did the factoring of only the 2 terms, not out of all 3 of them. What goes in the first box? 4. What goes in the second box? 8 goes in and we subtract 8. It's 8 though, because remember if there's a 2 in front, we can multiply that by 4 before you do it. So vertex form, 2, parenthesis, x, what sign is it? Plus 2 squared minus 1. Vertex is -2, -1. AOS, x equals -2. Y-intercept, f of 0. We're doing 2 times 4 minus 1, 7. Yes. It's hard to read messy handwriting.
Oh, trust me, yeah, I tell my
Yeah, I know. I have to read it all the time. Okay, and then from there we're going to do the x-intercepts. You can also tell which intercept it is because I'm making the other letter 0. So I'm doing the x-intercept, I'm going to make the y 0. Then we're going to add the 1. And then we're going to divide by 2. So what do I need to do at this point? Matter, what do I need to do? Square root, but what if I square root? What do I have to also do? Plus minus. Okay, so when you square root 1/2, you can square root the top, but you can't square root the bottom. We would have square root, but we would have 1 over square root of 2. Because I can square root the top, but not the bottom, so what do we need to do? Rationalize it. Square root of 2 over square root of 2, so I get plus minus square root of 2 over 2. And we're going to subtract that 2. We'll have -2 plus or minus square root of 2 over 2. There are different ways you might see this one written. So it might look like -2 plus or minus 1/2 square root 2. Those are the same, because if you divide by a number, you can also multiply by its reciprocal. You might see it written with a common denominator of 2, which would make that -4 plus or minus square root of 2 over 2, like the whole thing looks. So you might see it written that way also. Okay? Questions?
Explain the last answer.
I made -2 into -4/2. And then I wouldn't do it that way. Since they both have the same denominator, I added their numerators over the same denominator.
Oh, I see.
I don't think I would see you guys do that. It's easier to type on my calculator if it's like that. But this way is fine too. Okay, this way is fine too. All right. So then, if you wanted to check your answers, you could use your graphing calculator, and hopefully you took good notes on that. Or else you could go watch the video if you forgot what to do, you can watch the video. Okay. Oh, before we do this, there are some questions in your homework that asks you just to find the x-intercepts. There's a few questions that ask you just to find the x-intercepts. So without all the rest of the work, how do you find the x-intercepts? Without finding the vertexes. How do you find the x-intercepts?
Is this an
It's not in there, I'm just like threw it on there. How do you find it? You plug in 0 for the y. And then how do you find the x-intercepts? So we could complete the square. We could factor out the x, it's GCF. We could do quadratic formula. You have different choices. What's going to be the least amount of work for this one? That's going to be the least amount of work. If you do complete the square, you have to like add stuff to both sides, plus it's going to be a fraction. And then you have to like square root both sides, and it would be a lot more work than just doing this. If it factors, factoring is always going to be the least amount of work.
That was an even number, we should have completed the square.
What'd you say?
If that was an even number, we should have completed the square.
If it factors, factoring is the most efficient, fastest way. Okay, and then our x-intercepts would be x and our 0 and 7, if it was like that. So I gave you a few to just practice factoring and solving. Okay. The last part of 2-1 is given information, writing the equation. These two examples, for example 6, we're going to write the equation of the parabola in vertex form. So we're going to do vertex form. So let's start with vertex form. What is it? Y equals, or f of x equals, it says the equation, you can do y equals. Y equals, what comes next in the formula? For vertex form, what's next? Before that. A. I don't know the A value. I'll put it as A. Then it's x minus h. Do I know the h value? -2. So x minus -2 plus 2. Squared. Then plus k. Plus 5. So vertex form, A parenthesis x minus h squared plus k. I plugged in my h and my k, but I don't know A. But what I do know is I know another point. So to find A, we're going to plug in this other x and y in for x and y. So 9 equals A times 0 plus 2 squared plus 5. So I'm going to square the 2, multiply by A, I get 9 equals 4A plus 5. Subtract 5, we get 4 equals 4A. Oops. So A is 1. So when you know your A value, you put it in. I did put it in, even though you can't tell because it's 1. But it would go right there. All right? So next one, first step. Don't worry, we'll dance real soon. We're going to dance. Next one, what's your first step? Yeah, we're going to do it real soon.
Much real soon.
When we finish 2-1. And we'll take a quick mental dance break. Y equals, do I know A? Parenthesis, x minus h, do I know h? It's -1/4, so x plus 1/4. Squared, plus k, 3/2. So how am I going to find A? Plug in the other point. 0 equals A times -2 plus 1/4 squared plus 3/2. So I'm going to have -3/2 equals A times something. So to add together fractions, we just type it in our calculator because that doesn't help us get any smarter, right? while we're taking notes, we're at least going to do it by hand while we're taking notes. So -2 is the same thing as -8/4 plus 1/4 is -7/4 squared. So now I have -3/2 equals a times, I'm going to square this, and what do I get when I square a fraction? I'm going to square the top and the bottom, 49/16. How do I get a by itself? So I'm going to divide by 49/16, but I'm not. So instead of dividing by a fraction, I can also multiply by its reciprocal. I'm going to multiply by 16/49. That cancels that out over here. On the other side, I can reduce the 2 and the 16 before multiplying to get -24/49. A. So I put my A value in, -24/49 multiplied by x plus 1/4 squared plus 3/2. Almost there. Ready? No? Okay, you were talking to Lyndon.
Oh, was it? That wasn't. I was like, that was it. We're talking. Oh, this is.
Okay, the last two examples from 2-1, we'll leave a little tiny bit of 2-2 still today, but for 2-1, the last two examples, we're now going to write the equation in quadratic form. One that opens up and one that opens down, so we're writing two of them. That has the given information. So here it says it has the x-intercepts. So what we're going to do is we're going to work our way backwards from, instead of solving to find the x-intercepts, we have the x-intercepts. We're going to work our way back up to unsolve it, I guess. So we have the x-intercepts. That means that x equals -1 and x equals 3. That's what that means. And to get that, like we had factors and we had to set them each equal to 0 and then we solved for x. We're going to go backwards. So right now we're going to set these equal to 0. So x plus 1 equals 0, and x minus 3 equals 0. And I'm teaching you this method on purpose so that it will be useful when you have harder problems. Okay, you can do tricks and shortcuts to get the answer faster, but I'm doing it this way so you know how to do it when you have harder stuff. Okay, from here, this is a factor and this is a factor. So we have f of x equals, and then we're going to have some value a, parenthesis, x plus 1, and a parenthesis x minus 3, where the x plus 1 to x minus 3, those are the factors. And this says that we need one parabola, one quadratic that opens up, and one quadratic that opens down. What value of a could it be so it opens up?
1. Or any plus is greater than 1. Or is that?
It could be 1. It could be greater than 0. Anything that's, what did you say?
Greater than 0.
Anything greater than 6, so we said.
It's
So anything that's what kind of number can a be? Positive. Now if I want it to open down, then a can be any negative number. What number would you like to choose? Let's go with 1. Let's keep it simple. Let's do that. So let's make a 1. And then we have to multiply this out to put it in quadratic form. So how am I going to multiply two binomials? FOIL. So f of x equals x squared. We do our outer and our inner at the same time. Minus 3x plus 1x minus 2x. And then our last minus 3. So there's our f of x. and it's multiplied by 1, so it doesn't change the value. That's nice. You really can pick any A, but I'm going to pick 1. Then we have to do a second equation. But this one has to open down, but have the same x-intercept. So it's going to have the same factors. It's just going to have a different number out front. What number is going to be out front so this one opens down? Any negative number. What negative number would you like to choose? 1 sounds good. Now, when you multiply 3 things together, you don't have to multiply left to right. When you multiply everything, you can multiply in any order you want. So I'm choosing to multiply these 2 together first. Why? Because I already did it. So I'm going to take that answer and multiply by -1. Negative x squared, what? Plus 2x plus 3. Done. Okay, we gotta go through the last one. Because the last one has something different in it. It has a fraction. I'm gonna show you what to do if you have a fraction. Okay, last one. Same steps. We're gonna set each factor, or each x-intercept, x equals that number. We're gonna start with that. And then we're going to make it say equal to 0, except for that fraction one's got an extra step. So this one's going to be x minus 3 equals 0. This fraction one, what you want to do is you need to cancel out the fraction first. Totally. I was just trying to hurry and get to the next part, but I didn't. Cancel out fraction. Okay, so if you have a fraction, you need to get rid of that fraction. And how can I take this equation and cancel out the fraction? Multiply by. Well, I'm not going to multiply by the reciprocal. I'm just going to multiply by the denominator too. That way, it will be -1 on that side.
Do I need to do something else with that though?
Yeah, still. One more time. And then I make it say equal 0. So you'll need to get rid of the fraction if there's a fraction in it to write the factors. So f of x, what would you like a to be for the first one? 1. Okay. So we'll have x plus 3 and 2x plus 1. And for g of x, -1. So I'm pretty sure in the book it says there can be many different answers. That is very true, but if you want to give yourself less work, choose a smart A. And then you just FOIL it out. You really only have to do it once if you choose the same number. I'll put it back up.
Recording any?
Not during our dance. Okay, so if it is even, it's always going to rise in the same direction. If it's even but negative, they'll both be down, but they're both be up if it's positive. But what happens in between is what you're going to have to figure out still. So we could have like an x to the 8. And we know the x to the 8 is going to look like this at the very ends. Don't just do that too close. It's going to look like this at the ends of it, but in between, depending on what other numbers are here with the x to the 8, there might be other terms. It might go like this. You may have other stuff happening. Okay?
Like based on
Depending on what, like if there's a 4 here, and then there's like a minus 7x to the 6, plus a 4x to the 5th, and so on. Depending on that, different things are going to happen in between. Today we're only focused on what's happening at the very end. The very end is called the end behavior, and that's what we were just dancing about. The end behavior. Okay, so there is a leading coefficient and degree test to tell the end behavior. We just did the dancing. But what you're going to have to do is you have to learn symbols, how to write it. So when I write these, I'm going to put in the middle a sketch, And then on the left side and on the right side, I'm going to write the answers. And these answers are going to be using symbols that you are learning right now. You may have not done before. So this tells us the degree is even. Degree, by the way, is the power. Okay, the degree is even, and the leading coefficient, the first coefficient, is positive. So if it's even and positive, what's the graph going to look like? So we know the graph is going to look like this and this. I don't know what happens in between. But I know it's going to look like this and this on the ends. So we're going to talk about the end behavior. On the left half of the graph, what is the graph doing?
Down.
On the left half,
I mean, it's going up.
it's going up. No, I'm just talking about on the left side,
It's going up.
it's going up.
Yeah.
So the declining in numbers is the left, right? Correct? The left means x's are going down. When I say left, I mean x's are going down. But the graph itself, the y values are going up. So we're going to say that using symbols. The y values is the function, the f of x. So you're going to write f of x. And then you're going to use a symbol that means approaches. And it's an arrow. And it always points that way. Regardless of which way it's going, it always points that way. So you're reading this as f of x approaches. So the function is approaching positive infinity. It's going up. That's what I'm saying right now. As the x values, so on the left, the x values are going to the left, are going to negative infinity. So as x approaches negative infinity. So this is how we say it in symbols. We say the function approaches infinity as the x values are approaching negative infinity. That is saying it goes up as we go to the left. So on the right side, we go over and we look on the right side. The function is going where? To positive infinity. It's going up. As our x values are going, if we're talking about the right, the x values are going positive infinity. So this is when I say you need to write your answers as symbols. This is what I want to see. If you look at the back of the book and you copy what they have, it's not going to look anything like this because the book did not have you write it this way. But you're writing it this way. Okay? So let's do the next one. So the next one, I'm just going to sketch the graph. And it says the degree is odd and the leading coefficient is positive. We just danced a bunch, so you should know what it looks like. Degree is odd. Leading coefficient positive. Something like that. Who knows what's in between? But I know it looks like that. So we're going to start on the left side. F of x approaches. So we're going to start with the y values first. The function is going down. So negative infinity. As my x values are going to negative infinity. The left side always says the x's go to negative infinity. The right side, the function is going where? Positive infinity. It's approaching positive infinity as x is approaching positive infinity. Okay? If you are not taking good notes and you don't know how to do this, I don't know what to tell you. I'm just going to miss everything, I guess. Next one, I'm just going to sketch a picture. It says degree is even and the leading coefficient is negative. What does that mean it's going to look like? Something like this. Maybe it has weird stuff in the middle. I don't know. Depends how high the exponent is. So the function is going where to the left? Negative infinity. as x is going to negative infinity. On the right, the function is approaching down negative infinity as x approaches, when x goes this way, it is positive infinity. The second part of each one of these is always the same because it's always left or right. The second part is the x's. It's always the same every single time. So our last example, if the degree is odd and leading coefficient is negative, what's it going to look like? Odd, negative. Look something like that. So on the left side, what's happening? The function is going where? Positive infinity as the x is going to negative infinity. Always, x's are always the same. The second part of that is always the same. On the right side, f of x is approaching negative infinity as x approaches positive infinity. On the next page are what the homework would look like. There's 2 examples. So the homework's not going to say these words. The homework's going to give you an equation. And it's going to say something about describe the end behavior. And I want you to write it in symbols, just like we did. So the first thing you need to do is figure out what the degree and the leading coefficient are. And heads up, this one's not in the right order. Look at it. It's not in the right order. So if you did it, you'd be wrong. If you did it off the first one, it'd be wrong. You have to reorder it. What is supposed to be our first? So make sure you check the order. Then we can figure this out. So our leading coefficient, LC, our leading coefficient is negative. And our degree is 3, so that's odd. Yeah. No. This is me writing notes out so that we can compare it to what we were just doing. So if the leading coefficient is negative and the degree is odd, I know it's going to look something like that. I don't know what's happening in the middle. That's a mystery. But I know it'll look like this. So on the left side, f of x approaches what? Positive infinity as x approaches negative infinity. Left is always x going to negative infinity. And then f of x on the right side, f of x approaches negative infinity as x approaches positive infinity. Yeah, I just wrote degree, but I didn't learn how to word degree. Okay, there's one more. Can you figure out the end behavior? That's the right word. Can you figure out the end behavior? If you got it, grab a book and I'll put the assignment well, it's over on the side too. I'll put it up in a second. I personally feel it's helpful for me to have it, but it's not. a requirement. Okay, when you do your assignment, I try to put words up there so you know what to do. It just looks long because I put a bunch of words up there. It's really not that long. So for page 116, 31 and 33, that's the first examples we did where you had to like move it into vertex form and find all the information. And then 58 to 62 even, that's where all you have to do is solve for x-intercepts. 44, don't take a picture, hang on for 44, 46, 66, 68, you just follow the directions. Page 130, 1 to 8, you're going to use leading coefficient and degree, not your calculator. So when you get to that part, you're not using your calculator for 1 to 8. And 14 to 22, that's going to be writing symbols like we just did.
I'll take pictures of it.
Didn't want to be in the picture.